I'll be presenting part of my research on impact of urine diversion on Central Park wastewater treatment plants. So these are uh, these are some of the contents that I'll try to cover in my presentation. A bit of background and scope of urine diversion, followed by the research case study that we have performed on Central Park wastewater treatment plant, and some of our key findings and future options. Yes, so let's get started by understanding the common wastewater sources. So the common wastewater sources include urine, feces, and heavy grey water from dishwasher, chin tap, and washing machine, and light grey water from sources like bathroom tap, shower. And in a traditional flow, all these combine in a common wastewater pipeline and are carried to the wastewater treatment plant for further processing. So, when we try to look at the composition of wastewater, urine contributes to about 1% of the whole wastewater volume. But this 1% of the wastewater, 1% of the volume from urine contributes to about 80% of nitrogen in wastewater and about 55% of the phosphorus in wastewater. And in a traditional flow like Central Park, all these nutrients are carried to the wastewater treatment plant. And the general treatment targets of the plant are to remove nitrogen, phosphorus, organics, and pathogens from the wastewater. However, some of the challenging parts of this process are nitrogen and phosphorus removal. At Center Park, nitrogen removal is carried out by nitrification and denitrification processes, where ammonia in the wastewater is nitrified to nitrite and nitrate, and then denitrified in the form of nitrogen gas. One of the challenging parts of this process is that it requires energy-intensive aeration, which consumes about 40 to 60% of total energy consumption. This process also requires recirculation, which increases the space requirement of the total plant. At the same time, this process produces harmful greenhouse gas emissions like nitrous oxide. And phosphorus removal at Central Park is carried out by chemical precipitation by alum dosing, which requires alum as a chemical input. And according to my calculation, about 31,000 per dollar is spent on just purchasing the chemicals required to carry out this process. At the same time, in this process, the precipitated phosphorus is discharged to city water sewage pipeline, which charge based on $6 per kilogram of phosphorus, which is discharged to the city water. And my estimates show that about 40,000 is being spent on just discharge to phosphorus every year. Also, one of the other challenging parts of this process is that this by alum dosing, the salinity of wastewater is increased, which at a later stage would have impact on the performance of RO. So, so one way to challenge this process that we are proposing is urine diversion, where at the source you're removing a major part of nitrogen and phosphorus from wastewater, which can lead us towards sustainability. Uh, so we have proven at UTS that urine diversion is possible from male urinals. At UTS, we have a plumbing system which diverts urine from all the male toilets. It has a common pipeline which takes all the male urine to the basement, and further, this urine is processed to be used as a fertilizer. Sorry, my presentation is stuck for some. Okay, so assume if Center Park wastewater treatment plant had a similar plumbing system which it could divert urine. If it did, we would remove a major part of nitrogen and phosphorus from wastewater with urine diversion, which is expected to have significant influence on the some of the process performances of the Center Park wastewater treatment plant, like energy consumption, greenhouse gas emissions, and effluent nitrogen loads. So my work is focused on modeling this scenario and understanding how it can impact, how this process can impact the performances of Center Park wastewater treatment plant. To carry out this work, we we have uh, we have carried out this work on BioWin modeling software, which is used by most of the water utilities in Australia to optimize the treatment process and in order to study various treatment process in wastewater treatment plant. So our model input was Center Park wastewater treatment plant process. We configured this process on BioWin modeling software, calibrated and validated this software, and the model outputs were energy consumption, effluent water quality, and greenhouse gas emissions. So first, we validated our model with real data from Central Park wastewater treatment plant on effluent quality and energy consumption. And from our comparison, we saw that our modeling data was and real data were within less than 10% error range value. Our modeling studies have revealed that by diverting about 90% of the urine, you can save up to 33% of your energy consumption because urine diversion, you're not letting most of the nitrogen coming into the treatment plant, which saves a lot of aeration energy. At the same time, with 90% urine diversion, about 25% of your greenhouse gas emissions are reduced because you are cutting down on the nitrification and denitrification process. We found that with by diverting urine, the effluent COD remained more or less the same until 90% urine diversion. But further, more than that, nitrogen limiting conditions occur in the treatment plant, which lead to shoot up of COD for more than 90% urine diversion. And we also found that by diverting urine, you are reducing the discharge of nutrients into the Sydney Water Sewer Pipeline, which reduces your nutrient discharge costs. And our calculations show that about 23% of your costs on nutrient discharge can be reduced. So these are the results we have so far. To sum up, with urine diversion, you can save 33% of your energy consumption, which will have an impact on the OPEX costs of the treatment plant. 25% of the greenhouse gas emissions, which would have an impact on the climate change, and again 23% of your nutrient discharge costs, which would have an effect on the operating costs and lead us towards circular economy. So these are some of the benefits that we have investigated so far, and there are many more benefits that are yet to be investigated. Like we are interested in investigating the effect of urine diversion on the plant footprint uh, and capital costs of the plant, and also treatment capacity of the plant, which can which can benefit the treatment plant significantly. So these are our results so far, and I would like to conclude by thanking you all for the attention, and I would also like to thank Sanjay and Altogether Group for giving me this opportunity to share my research, and I would be happy to